So in number 2, after we are done, all right, reading through, looking at our graph here, our diagram. For a transverse wave, we have crest as our top point. The dashed line or the center line could be your equilibrium position or resting position. The bottom points we would call troughs, spelled T rough, R-O-U-G-H, T-R-O-U-G-H. And then an amplitude is from the resting position or equilibrium position to a crest, or from that position down to a trough. So the next thing that they would like us to do is to draw a horizontal line to show a wavelength on the diagram. And so what I'm going to do is I'm going to take this and I'm going to Control C. I'm going to copy it. Then what I'm going to do is I'm going to go in, click in here for part C. Okay, so what we're doing, we're click on this guy, we copy it, come down here to part C. You're going to go to Insert, Drawing, New. Insert, Drawing, New. Once you open that up, I'm going to paste the image. Control V. I'm going to just click on this, make it a little bit bigger. And so what is one wavelength? Well, from what we talked about before, the wavelength, okay, is the length of one cycle. So back in the video that we had looked at as well, let's see, was it? So the wavelength can be from crest to crest, from trough to trough, or from the equilibrium position, and you have, it's a third time it crosses. So if this is position 1, 2, 3, that would be one complete wavelength as well. So the easiest one to do, though, is probably just to go from crest to crest. So I'm going to make a line, and the line is going to go from U to U. I'm going to turn it red, and then I'm going to go to the line weight button here and go to 3 times to make it a little bit bigger, make it pop. So that red line that we just inserted would be your wavelength. So if you guys couldn't do that, or it was too much of a pain, I'm telling you to do this right now. You can screenshot this. If you click on the meet and you pin my whatever to the screen, it should make it a little bit bigger. And then you can screenshot that and then paste it in your answer box there for letter C, and then you can just crop it down to where you need it to be. Now, in letter D, they want us to do the same thing but label an amplitude. Okay, so what is where does the amplitude look like? Amplitude is shabam, from here, from the resting position to the top. So that would look simply like this. I'm going to click on here. I'm going to go to Insert, Drawing New again. Still paste my old picture down. Expand it, and then yeah. So from the resting position, which is our flat horizontal line, to the top of a crest, that right there, that could be an amplitude. Also, from the trough to this guy, that could also be an amplitude. God bless you. So you don't have to necessarily draw that, that exactly how I did it, but this would be, guys, what you would look like, or what it would look like for your part D, letter D here, to draw in this guy and show your amplitude. All right. Ooh, this is a good one. Use this diagram, all right, to answer E and F. What type of wave is this? Is this longitudinal or transverse? Well, if we're not sure, right, this is kind of what our transverse wave looks like. It's kind of got like that up down, looks like a sine curve or a cosine wave. And then your longitudinal is like a flat line that's got compressions and stuff like that. So this would be transverse. So you'd write the word transverse here in letter E. You'd write the word transverse here in letter E. What are we writing in this spot?
Transverse.
Okay. Now, how many of these do we see in the picture? How many crests are drawn? 3. So you'd write here 3. The top. The tops are crests. The troughs are the bottom points. So how many we got there? 1, 2, 3, 4. How many amplitudes do we see? 7 is correct, and I'm just going to show it real quick. Remember, it can be from resting point to trough, so that would be one of them. And it can be resting position to crest. So 1, 2, 3, 4, 5, 6, 7 are shown. And then wavelengths. So wavelengths, that's a little tough, right? We said that crest to crest is a wavelength, correct? So from here to here is 1, and then from here to here is 2. But there are other ways you can count wavelengths. You can do trough to trough. So if I said, hey, from here to here is 1, 2, and then 3. But then it's still not everybody, right? We still have like this little piece here, this little spot, and then this spot over here. So what is going to be the easy, or what is the best way? So like in the video, if you were to start here, all right, at an equilibrium position, and then if this is like 1, 2, 3. So what we should have is it looking like this. So if we're starting here, 1, right? If this is 1, 2, 3, that is one whole wavelength. And how do I know? Because it does a complete cycle. It goes down, up, and then back to the center. So that is 1. And if we continue with that, then we have 2, and then we have, right? Wow, that my mouse just kind of bugged out there. What are we doing, mouse? Three. And then what about this? What is this? That's a half wavelength. Good. So we would have 3.5 wavelengths. Okay, so amplitudes we said was 7, and then this dude we said was 3.5, 3.5. All right, the next stop, what is this diagram? What kind of wave is this? Good. The longitudinal, yes, the barcode. Longitudinal. All right, so this one is a longitudinal wave. So now we're looking at this guy here. It's longitudinal is how they pronounce it, like latitude, longitude. So it's a longitudinal wave. Okay, so then it wanted us to label each compression and rarefaction. So that's a pain in the butt. So I'm going to show this, and then you guys can screenshot my end. So I'm going to copy that, and I'm going to insert drawing new, paste. It's just a little bit bigger. Okay, so what are the compressions? We'll label it C. The compressions are, what do you think? The spots where they're closer together or farther apart? Closer together, that only makes sense. So this guy would be a C. Right here, right? That looks good. And then what about, is there any other one? Yeah, right there, that guy. Okay, so then the rarefactions are the ones that are kind of in between the compressions. So I know for sure, right, in between over here. All right, we got an R. And I definitely know that this one right here is also R, a rarefaction. Are there any others? Yeah, I would say at the very, very end, we would be starting with the rarefaction, and at the very beginning. So at the very beginning, and out here at the very end. So if you screenshot this picture, crop it, this will be our rarefactions and compressions. Okay, what two parts of a transverse wave correspond to compression and rarefaction? Well, I would say the crest would equal the compression. That is not where I wanted to write. What did I do? Jesus. All right, I would say that crest is equal to the compression part of the wave, and the trough would equal the rarefaction. Now, how many wavelengths are listed? So how did we figure them out on rarefaction? How would I figure the wavelengths out on this dude? Well, on a transverse wave, we said crest to crest. So we could do compression to compression. But also on a transverse, we can do what to what? I'm sorry, also on a transverse, we can do a trough to trough. So because they start with the rarefactions, we would say probably make the most sense to go from trough to trough. So from this guy to this guy would be 1. From here to here would be 2. And then from here to here would be 3. So the answer should be 3. If you were looking at just compression to compression, because it doesn't start with them, you would just be like, oh, well, you have 1, 2. But that leaves out these little spots over here. And if you added them together, a half and a half make a full one. So from trough to trough, or rarefaction to rarefaction, you can get a wavelength. So how many waves are illustrated? 3. 3, measuring from trough to trough. Cool. Complete the check your understanding and document your answers below. So this one, I think we needed, is it the same one? It is. So here's your check your understanding. All I'm going to do is when I go to this, I'm going to copy this picture, copy this image, and I'm going to paste it here. What letter corresponds to the wavelength here? What letter corresponds to wavelength? Not B. Well, all right. Well, D would be the correct answer for amplitude. That would be correct for amplitude. But for wavelength, what would that be? Yeah, hey, good. And then for the last one, they wanted this picture. Okay. Indicate the interval that represents one complete wavelength. So they want one complete. Amplitude was letter D. So in this case, they wanted one complete wavelength. So the only one that works in this, right? So from crest to crest would work. So if they said B to F, that would be great. But it's not. If they said A to E, that is a complete wavelength, right? But that's not an option that they give us. B to D, no, that's a half. A to G, that's more than one. So the only one that actually works is C to G. Starting here, point 1, 2, 3. There you go. That is a complete wavelength. So that would be your answer. You would write C to G. All right. Now, if you click on this piece here and open up this link, this is what you guys would use to get and complete through these dudes here. So period and frequency, kind of just got to read through. You can, what is frequency? You copy that, you can paste it. What is the period? Okay, you can copy that and paste it. Just read through it. What I want you guys to do is also I want you guys to get rid of letter D here. Get rid of letter D at the bottom. And I will just answer C real quickly. So on this, if we don't change the amplitude, all right, look at the spacing between the crests here. This is when the frequency is at medium. As the frequency increases, right, so the distance between crest to crest is our wavelength. So if I increase the frequency, what happens to that distance between crests? Let's go to very high. Oh, gotta hit plot. Silly me. Wow. Yeah, the wavelength decreased a lot because in the first one it was like from, I think there was like 2 crests from 1 to 2. Now you got almost 4. So as our frequency increases, the wavelength is going to decrease. So those guys are inverses of one another. So guys, please make sure that you're not doing letter D. You can erase letter D. All right. And then you guys should then have the link to look through, answer these 2 guys here. We answered letter C, no letter D, and then we answered these guys here. We pretty much went through all of, yeah, basically part 1 and finish 2 other questions down at the bottom. Okay. Okay. That'll be it for the day, guys. Please make sure that this gets complete. All right.